Welcome to SystemVue. In this tutorial, we're going to look at the ModelBuilder interface and do our first C++ model. We'll be using the basic SystemVue product and also a free download from Microsoft, the Visual C++ 2008 Express Edition. In this tutorial, one thing you can do to prepare is to install the Visual C++ Express Edition. You can do so by going to this website, Microsoft.com Express Download. On this download site, you want the Visual C++ 2008 Express Edition. The next thing you should do is go to the manuals. Under the User's Guide, User-Defined Models, C++ Models, you'll see a section that you can print out that has this discussion to follow along at your own pace. In this demonstration, we'll set up a new project in Visual Studio. We'll enter a C code model for an adder. We'll compile it and link it into SystemVue. You'll be able to place it on a schematic. We'll build a schematic to test it, and then we'll actually get into debugging and using breakpoints. If we have time, we'll look at some other examples in the system. So let's get started. The first thing you should do is go to your installation directory for SystemVue 2008. Go to the ModelBuilder directory, and under that directory is a SystemVue ModelBuilder directory. Take this and copy it to your Visual Studio 2008 projects directory. Under projects, I'm going to copy it. Copying these files to the Visual Studio working directory gives you better access to some of the files. So now let's run Visual Studio. In Visual Studio, we're actually going to start from scratch. So let's go New, Project. We select Win32 Console Application and begin typing My First Library. We hit Next. We choose DLL, Empty Project. We now go View, Property Manager. We right-click it and say Add Existing Property Sheet. Okay, at this point we have to go look for a properties file, and I've navigated to my SystemVue installation directory, and under the ModelBuilder directory is a VS Props. We select that. We now go to our project and add a class. It's a C++ class. We're going to call it Adder. And the base class is Agilent ESOF : DF model. Okay, we have a header and a CPP file. The instructions in the manual tell us what to type, and I'm going to pause the video and complete the typing. Okay, the structure of this is that we are defining the two inputs, an input and an output. In fact, made a typo. I'm going to change the order. And the output is defined here with a parameter for gain. I test the gain. If the gain is equal to 0, here using this construct, I can export an error message. And then finally, the output node is equal to the gain times the input plus input 1 plus input 2. The header file sets up various declarations. With this, I will build the solution. It succeeded, and we're now ready to link it into SystemVue. To inspect it, we can go into the operating system and look at our new library and see that we have a debug directory that has a DLL ready to go. Okay, let's go back to SystemVue. We'll go to the Tools Library Manager, and we will enable that by adding from File. I'm going to change the type to DLL and go to the Visual Studio directory under Projects, My First Library, Debug, My First Library. When I look, this is now enabled. Here's my first library models. When I close and go to the parts selector, I now have a My First Library with an adder, which I can place on a schematic. So now let's here's our adder, and let's now build up a circuit around it to test it. I'm going to look for a constant, and the tutorials call for a ramp. I'm going to change this data flow to be 10 points long. We'll change the value of this to be some number that will be obvious to us. And let's get a measurement point, a sync. And with the sync, we'll turn on an automatic table. At this point, it's always good to save your work. If I run the analysis, I get an error message. And lo and behold, the error says the gain can't be 0. So our error message works. If I turn the gain to be 1 and resimulate, the error message goes away, and you can see that the values, the ramp goes from 0 to 9. I have 10 points, and 0 to 9 plus 4.5 gives us our final value. So we verified our model. The next thing I'd like to show you is what happens when I take that library manager and I remove my first library model. I remove it from my list of libraries. Notice that it had given me a symbol, an automatic symbol. It read my input ports and my output ports, their data rates, and had given me an automatic symbol complete with a parameter page. Well, that when I remove that library, this is now unresolved, so you can see the effect of the automatic symbol. Let's go back and show debugging at this point.